Hi, today's lecture is System Verilog. Before this, there is a Verilog code. Mostly Verilog code is for designing of the circuit. For example, if you open this watch, there is one circuit. Okay, on that black color will be there. That is a chip. Okay, that chip before it is fabricating, designing, we need to verify as per functionality it is working or not. So what we will do is we will verify in several levels. Among them, we need to verify right now for our course or for our job. We need to verify only one level. That is level is nothing but formal level. In that formal level, what will happen? What will happen? What will happen means there is a logical statements will be there. We will we will give simple programming. We will give the design is also a simple program. It's not an actual circuit. This chip act, it is not the chip we are verifying. We are verifying what is there in the chip. That circuit we are writing a program that is called design. For that design, uh, we will check whether it is working as per requirement, as per functionality, as per the spec. We will call spec document. Spec, it is verifying or not. For example, if I take and gate, okay, it two input and gate. In that A and B two inputs will be there, and you know the truth table. Y will be one if two inputs are one, or at least one is zero, then output is zero. You know that. But how will you verify that? By giving different input to the circuit. The same thing, that this is called verification. While giving same input, different inputs at the input, and taking output and comparing, that this output is called expected value. Maybe why expected value? Maybe design may be some wrong. Sometimes design may go wrong. So we can't tell directly that this is the actual value. So this is perfectly key. If we know that this is perfect one, then we don't want to test it. No need of testing. So here we will give different combination of inputs. For example, if I'm giving uh, direct stimulus, which means all the inputs from the 00, 01, 10, 11 to my AND gate, and I'll check at all once. If I give all ones at input, then my output should be one. If I give at least one zero, then my output will be zero. That is called functionality. That functionality will check. This is called functional verification. Here we will write simple programming only. For that, you need to know few basics. Those basic things I'll go through now. Whatever I'll explain in the course, please go through those course only, read it, understand it, and ask if you have any doubt. Other than that, there is so much document in the internet. You follow only this document, whatever I told. Okay, this is more refined way. So please follow this. So I'm sharing the screen. I'm okay. Okay, I'll come from the beginning. Okay, verification. guide, verification guide. This is the first one we need to choose. In first one, you will come system verilog. This components are this. Don't go further. Here EDA playground mentioned. This is the tool where we will uh, execute, we will run the code. So among them, system verilog, UVM, system C, interview questions. System C we will not see. System verilog we will see. Okay, this is the field we need to click. Once you click the system verilog, about introduction. Okay, about, no need to go all those theory. Simply I'll tell in two statements. System verilog is a verification methodology. This is also called test bench. Even in your verilog also there is a test bench, but that is for small designs. If design is increasing, then we can't use verilog test bench. We need to go for system verilog. The system verilog is not only for verification, but also we can use for uh, design in a best way, because it have rich resource of elements. So system verilog tutorial I'm coming. Okay. In this introduction, introduction about system verilog, introduction to verification and system verilog. Okay, data types. Okay, integer void enumeration, string event enumeration example, user defined. So arrays. See, if you want to use any collection of data, then you definitely need array. In that array, you have fixed array, which means you need to design at the design time only. You need to, with array variable, you need to design which locations you want. That is fixed size array. Unpacked and packed array, I'll explain. Dynamic array. Okay, what is dynamic array? I'll explain. Which means here we will assign memory locations at the runtime. Associative array. In associative array is like a sparse array. Okay, it will it can it can take values based on how values are coming. For example, when data payload is coming, at that time we don't know how many memory locations we need to assign, so we will take it into the associative array. Here queue, mostly queues will be used for storing the data like an array. It can store any amount of data. This basic application is this we will use in scoreboard. That is one of this architecture in VLSA architecture. Okay, the scoreboard will be there. In scoreboard, we will take that data into two queues. That Q1 equal to Q2. That those two are same or not. Likewise, we will verify. That's it. Blocking and non-blocking statements. These are simple. I'll explain when it comes. Means unique priority. While do while. For each. This is also enhanced for loop. In for loop, how we will give for I equal to 0, I less than 5, I plus plus. For example, 5 elements, 0 to 4, uh, if you want to encounter, then you will give in a for loop. Here, for each 5. So the index start from 0, 0, 1, 2, 3, 4. That many times it will go. Repeat. Repeat means mostly it is used for the clock cycles. Iter, not for a iterative statement. Clock cycles. See, repeat 2 means 2 clock cycles. mostly it will be used in events. In the events, for 2 clock cycles, it will get saved forever, which means infinite loop. These things where we will use in scoreboard. Now you people don't understand scoreboard, what is scoreboard, how it look like, where we will write. But forever if you there we will write until all our packets came. Okay. Break and continue statements. Named block statement labels. Disable block and disable statements. Event control. Event means, see, it is used for the synchronization of this test bench. Here, test bench is not a single file. Okay, it is set of files and synchronized in a proper way, so that we will give pin level information data to the DUT, and we will get the expected output. For parallel processing, we will use fork join. In this fork join, we have four types: fork join any, fork join none. Okay, wait for, disable for. Tasks and functions are methods. Only these two things we will use. With the help of this, we will write the anything. Okay, whatever we want to write, that we will write either in a function or task. These are called methods. See, for example, function won't take delays, timing delays. Okay, it should complete in 0 time. So no delay elements will be present in the function. Task means it can take a delay. So that's why most of the test cases, which are most of the test cases run in task, assign, passing, classes. What is a class? I'll tell in a simple example. Class means like a blueprint of the building, and after creating object, it's like a complete house. Okay, in house everything will be there, like methods, parameters, everything. This keyword constructors. Constructor means creating a memory simply. Okay. Static class properties and methods. Class assignment. Shallow copy and deep copy. Copy means what? Copying file from one place to another place. In that two copies will be there. How we will declare? We will declare in a different manner. That I'll explain. Parameterized classes. See, for example, parameterized classes, we will mention hash, data width, class definition. Okay, hash, data width, or address width. We will mention hard coded value. And in the next child class, if you want to, or in the method, function method, if you want to override previous value and come and occupy new values, at that time we will use parameterized classes. Inheritance. Inheritance is simple. Inheritance means, in simple meaning also, whatever your father is having, that also, that is belong to you only. It's like parent class, whatever the methods are present, that methods we can access in child class. And mostly in parent class, that will be like a skeleton. Here in child class, we will give a body, develop. We will develop a code to build a body. Overriding class methods. Okay, how we will override? Super keyword I'll tell. Cast, very important. Data hiding and encapsulation. Abstract classes, virtual methods. Class scope, resolution operator, double double. External methods, type of classes. Randomization. Okay, randomization means, see, for two input, we are giving hard coded value 0 1 0 1 0 1 1. Likewise, we are giving. But if it is a 32-bit AND gate, then 2 power 32 combinations will come. So if you write that combinations uh, in a tool, the system will get crashed. It takes so much memory and time, and so it cannot go beyond that time, so it will get crashed. To avoid that, we will give refined manner. Okay, and we need to check corner cases also. What is corner cases in this? In 32-bit, how many, with minimum how many cases you can say that AND gate is working function? 2 power 32 means what? 4 giga. 4 giga combinations we need to give. But here, what will happen means, here first we will give all ones. We will check output should be one. So point is over. Next, we will check all are zero, only one bit is one. That one bit will be powered from LSB to MSB. Remaining all are zero. So you can check. So that will take 32 combinations. So 33. In 33 you can tell. And sometimes we will give patterns also. These are minimum. So that to avoid that, we will use rand keyword in that rand for the variable prefix. We will give rand keyword and we will randomize. After creating an instance, we will randomize it. Once we randomize it, what will happen means the random number of it will be generating. Only one time will generate. If you want to generate 10 times, then you need to repeat 10. That's all. 10 times it will generate, and it will give values, that is called log file, and also gives waveforms. Weighted distribution. This I need to understand. Distribution means it's like a probability kind of thing. There is a notation for that. For example, out of 10 numbers, okay, 0 to 9, 0 to 5 should come 70%. Okay, remaining 30%. Then it will modify accordingly, and it will generate. You need to give that statement only, it will generate automatically. Implication and if else. Iterative constraint block. Constraint mode. What are constraints means? See, constraints means refined. All inputs refined in a best fashion, so that those inputs only will go. Okay, in that, within the range of that constraint, those only will go to the DUT and will get the response. And in this, assertions are bidirectional. For example, if you wrote two assertions, one assertion is from ranging from A is ranging from value 25 to 50, and B is greater than 30. So it is bidirectional, and it will take consider from 30 to 40 only. See, by all conditions, you will take last assumption, that only it will take. Semaphore we will use for where is the semaphore? These are just indexes. See, you can't run everything in one stance. So better what we will do is, if we run these things, that is it. These are very simple, and there is a software also. Okay, that I'll explain. Okay, how to do it, and what we will do is, we will go first to, we will go for about system verilog. There is nothing, no need, don't read it. System verilog, I told everything. It came from verilog, and it have rich resource of constructs, so that we can build in a better way. Here it have whoops concept, that inheritance, polymorphism, encapsulation. These are called whoops, object oriented programming concepts. Those will be present here. Okay. So now, introduction to verification and system verilog. We will go to this point. This theory and all don't read it. Okay. See, this is the main functionality you need to learn. Generate stimulus. How you can generate the stimulus? Using the dollar randomize. Dot randomize. That is one of the randomization method. It will generate for the values of the class handle. Okay, in that only our pocket will be present. Okay, apply stimulus. Stimulus means inputs to the DUT. DUT capture the response. We will take the response output and check for correctness whether it is working proper. This only entire course. If you learn uh, if you learn system verilog, assertion or coverage or UVM, you can learn anything, but you need to learn a system verilog only. So these only you need to check. For that, how you will check? So I think till here, I would like to stop the session. Okay. Uh, don't go for all the components. You come to here, you understand this, and go. Go to see here. He has given proper name. Apply input stimulus. Input stimulus both means same only. Okay. Here, design under verification test. Get the output. Okay, this output and the reference model same like DUT will make, that we will compare. Same output is coming up. If it is coming means that's good. If it is failing means we need to identify. Okay, so don't read this. Data types you need to go through. Okay, here integer, void, string, event data types, user defined data type, enumeration data type, enum, class data type, structure data type. Integer means you know one, two, three, four. Likewise, any numbers. Okay. Void in methods, especially function, we will write function void means it won't return anything. That function won't return anything. If you don't mention void, then it will return something. Data, even data types. Okay, we will go through once. See, here it will come like table of contents. In this, system will have data types, structural data type, wire and rich. Okay, behavioral data types, integer, real and time, parameter, logic, void data type, uh, string and event data types, user data types. So if you go here, theory will be given. Don't read theory. I'll explain everything in a simple manner. These recordings are uploaded in YouTube and I'll share in the group also. Go through one to two times. You will get to understand. No need, no need to study all these things and all. Okay, wire reg. Reg means temporarily variable value. It will store. That's it. Wire means connecting between two components. This, if you don't assign any initial value, then reg initial value is x. Wire initial value is z. Okay. Behavioral data types. Integer, real, time. Integer means, see, this is 32-bit width. So this range from minus 2 power 31 to 2 power 31 minus 1. Okay, integer variable name. Okay, we'll see one. Hmm. See, integer a 0 down to 64, which means this width is, it is starting from 0. If you start from 1, then 64 only. It is starting from 0 also. So 65. The width is 65. And it is a integer. So that many numbers it can generate. Time. Time is 64-bit quantity that can be used to conjunction with the dollar time. Dollar time means it will, in display method, we will use basically dollar time to show exact time at what time when we run the test case, at what time it will be, that function is running, that will be written here. Parameters will be given like this. Parameters size 16. Okay. Logic. Logic is the improved version of reg from verilog to system verilog. So it can driven continuous arguments, gates and modules in addition to being variable. See here, actually, reg. Okay. If you use reg you need to use it only procedural block. Here you can't understand few things that later I'll explain. Those nomenclature, those names I'm taking and using now, so you don't get confused. This is for the beginners. So they, if you go there, yeah, we I will link up it so that it will go. So wise we will be using procedural blocks like always block. Okay. Always and initial blocks are procedural blocks, but mostly in always block only we will use reg. In assignment, continuous assignment statements, we will use while. There is a confusion if you interchange these things by simulator will throw an error. To avoid that, what we will do? Simple. We will use the logic. System will create a logic. You can use either like a reg or wire. It doesn't give an error. So better use it. See, bit unsigned. Okay. Unsigned means only positive values. Signed means negative also. Byte, short int, long int, negative values also there. Unsigned two state variables. Two-state variables means what? Two-state means only either 0 or 1. Two states. Those are states. If X or Z, that will be present. Okay. At that time, it is called core state. That we will see later. Int, byte, short int, long int. Okay. Its length integer is 32-bit. Byte is 8-bit. Okay. 8-bit sign integer. Short int 16-bit. Long int 64-bit. Unsigned from signed two-state machines. Int unsigned integer. Byte unsigned byte. Short int unsigned short int 16-bit. Long int 64-bit. Void data types. The void data type represent non-existing data. This can be specified at the return of the function. It indicates no return value. Void ante no return. ఇదంతా చదవాల్సిన అవసరం లేదు. Simply, if you see like void in a function, that function is also called a method. So you can feel like no return value should be there. These adds and all don't care. Only we want text. Syntax void function call. Okay. String declaration example. String means either string means ABCD 1 2 3 alphanumeric character. These are all strings only. Okay. String S1. Okay. It's a variable. I'm storing this value into variable. Double quotes hello world. I'm storing here. String S2 HI. Okay. This entire thing I'm storing in S2. B128, S3, B. See, this is how a module look like. Module starts with module name. You can give any name, your name, any your. Better to give a proper name so that it can understand. By understanding it, you can string declaration. Okay, here we are declaring a string that he is giving. So string S1. Okay, hello world. String S2, hi. Bit 31 down to 0, B 128. String S3, B set 128 to S3. Display values. How to display values? With the help of $display. Okay, double quotes in string 1, S1, 0% S. Yes, percentage S means 0% S means string S1 it will store. Hello world it will come. Next S2, hi this one will come. Next 128 B is 128, S3 is also 128 because B we are assigning to S3. So here, see the output. Output also you will mention. See, everything came as. But to practice, what we need to do is we need to go to EDA, EDA background, EDA background. They just log in with Google, automatically it will log in. You simply copy paste it. Don't write. As of now, you try to understand that all. After that, you can write. Your writing time is still there. Okay. For that, you need to select Go System Verilog. It is there. Simulators. Always use Alt Prepare Approve. Okay. Their star mark means it is not saved. So save it after running. After run it. Error. Sorry, we got an error. String number it is not taking this tool. Okay, let's see. See here. String S1, hello world. String S2, hello world. Hi, hello world. Hi, space, hello world. Got it? Likewise, you need to just copy paste it and understand all of now. This only the task for the entire system variable. I also will give few codes. Go through it. Thank you.